Hi, today I'm going to be hacking a machine on Vulnyx called Redis. Just in case you don't know what Vulnyx is, well, Vulnyx is a platform where tons of boot-to-root machines are hosted on, ranging from low to hard machines. You can go ahead and download the Redis machine by navigating to www.vulnyx.com and searching by the keyword Redis. Click the small download icon and you'll be referred to a mega download link where you can finally download the machine. Once that is done, you can go ahead and unzip the archive. Then open up VMware and import the .oba file. Take note that this is not limited to VMware only. You can also use VirtualBox or any other virtualization software that you like. Automatically, the machine should have the network set to bridge already. But in case the machine network is not set to bridge here, you can come over here and then set it by yourself. Also make sure to assign the desired RAM in which you want to give to the machine. I'm just going to click save right here and then I'm going to start up the machine. Now once you start up the operating system, this machine, which is ready, will begin to start. Once the machine is done, you get an IP address, which is, you can see over here, 192.168.0.116. That is the IP address that is given to the machine already. So you don't need to run an app scan. If there was no IP address given, you probably need to do something like sudo arp-scan-l and then hit enter. Then you type in a password and then this is going to discover the IP address for you. But since it has already given us the IP address, we don't need to do that again. So once that is done, the first thing first always, which I do in every CTF, is to run an Nmap scan. And your Nmap scan for a beginner might be simple as Nmap. That's Nmap-p Nmap-p, which means scan all 65,535 ports, followed by the IP address, which I'm probably going to replace here with 192.168.0.112 if I'm right. That's 116 rather. So once this is done, this is actually going to run an Nmap scan on all 65,535 ports and then perform a service, a script and a service scan, and then we are going to enable verbosity with -v option, which stands for which does Nmap to actually talk more. Also, we can add timing template, which is --min-rate, just to make the scan very fast, and then we can add 1000 in. Now this is going to start the Nmap scan, and then we are going to get all necessary information back to our terminal. As you can see, Nmap has already found 4 ports for us, which is port 80, port 6379, port 8080 and port 22. Also, you can see more information here. On port 22 you have SSH, on port 80 you have HTTP, on port 6379 you have Redis, and port 8080 you also have HTTP. Now you also have the version of each and every application which is here, of every application running which is here. So the first thing I do is I tend to enumerate for the web-based application or web-based port first. So I can go over to my browser and then just navigate to your browser and then navigate to the IP address to 192.168.0.116. As we can see, we have a default Apache web page here. through my methodology, the first thing I do is to actually view page source. But there's probably nothing in the page source for this box, so we don't literally need to view page source right here. Now, there's two ports on HTTP. First is the default port 80, and there is another default port 8080, which you can navigate by just adding a semicolon followed by the port number. Now we have this page, and the next thing to do is to actually run a directory book first. However, we can actually try to run a directory book first. We can use DRL search, that's DRL search -- URL HTTP, and we can also perform another DRL search -- URL on port 8080. So don't forget to do that on both or also. We are going to leave this to run. Meanwhile, we'll go and continue other stuff. Now we also have port 6379, which is actually a Redis web server. In order not to take too much of our time, I already have a blog here which talks about the Redis RCE. Now there is an RCE vulnerability in the version of Redis on this web application, and we can do that. Let's just go ahead and run our Nmap scan again. Now, because of the length of this video and time, I've actually pulled up a Redis RCE exploitation article here. The reason is I've solved this bug before, and I know that the box is actually vulnerable to Redis RCE exploit. Now, somehow using Redis CLI, we can actually connect to the box without actually providing any password, meaning we don't need authentication. How do we do that? You can just use the command Redis CLI followed by the IP address, which is 192.168.0.116. Redis CLI rather, not Redis CLI. So that will actually connect to Redis CLI. Now if we type in info, I think we'll actually get a lot of info which you can see here, meaning we don't need authentication to this particular machine. So now we can get RCE from this place. How do we get RCE? Using this particular exploitation script, we can actually set a config folder. We need to set a config directory, which is the web directory for the web application. Now, because this is actually a Linux box and it literally has a web directory. We all know that the web directory for Linux is okay. We all know that the web directory for Linux is /var www.html. So I'm just going to type that manually because somehow my keyboard is not working. So I'm going to do config set dir, and then just to make sure there's no other option here, I'm going to type in /var/www/html. Now this should give you an OK message saying yes, that is probably true, right? And then if you come over here, we also have set db name to grem.php. Now grem.php is going to be the path or the file where our reverse shell is going to be stored. Now I'm going to hit config set db file name, config set db file name, and then I'm just going to call it, you can call it whatever you like, you can call it rev.php. That's what I'm going to call my own, rev.php. Now we also have the last command here, which is set grem followed by this particular rev shell. That is the content of what is going to be there. So now we can paste that in there and then just hit enter. Once that is done, make sure to also hit save, and then you have that. Now what we need to do is we need to go to both web application where we have port 8080 and port 80 and try to see where we can actually read the rev.php script. As you can see in port 80, we don't have the rev.php script as it says not found. We're navigating to port 8080 and then going /rev.php, we actually have the rev.php file saying cannot execute a blank command. Now, just to prove the concept that this is available, I'm going to run the hostname CTF command, which actually provides the hostname of the system and other important information like the machine ID. Now, we are going to put a pipe sign here, and remember here we use the new parameter. So we are going to pass it to new, and then we are going to put equals to sign and then hostname CTF. Now, if you actually view page source, you are going to see the data much more presentable. As you can see here, we have the host name, which is ready, we have the VM, we have machine ID, and we have boot ID. Now, the next thing we can actually do is go to a site called RevShells, because what we need now is a reverse shell. So you can go over to revshells.com and get the reverse shell. Now, once you navigate to revshells.com, shout out to 0day, is the creator of RevShells of this website. So shout out to J0day. Now, once you are here, you can actually type in your own IP address. Make sure to come over to your machine here, hit the new tab, and then check for your IP address. I have different interfaces here, but I'm going to be using the one for VLAN 0. I'm going to paste this here, and then I'm going to set the port to whatever, literally, but I can use 444. I'm going to copy this command in the listener section here, and I'm going to clear my screen here and paste that command in there. Now, this automatically starts up a listener for us called with the netcat binary or netcat application, which gives us back our reverse shell. Now, we can actually go here and look for Python 2. I'm going to be using the Python 2 exploit, and I'm just going to copy this particular command, come over here and replace it with hostname CTF. Once you hit enter, you should actually have a reverse shell here, but if you don't get a reverse shell, it's actually fine. It is just that probably there is no Python 2 installed on the server, so you need to probably use Python 3. So just copy the Python 3 exploit also and go over to the URL, paste it and hit enter, and surely if you did the right thing, you should get a reverse shell. Running UMI here, we can actually see that we are Ben. As you can see here, we are Ben. Now, we don't even know Ben password, so let's take a break here. Why was this possible? Now, RCE is a very important vulnerability when it comes to hacking communities. I mean, it's a very important exploit also, because you can actually gain access to an organization or an individual, whatever device they use. If you have RCE there, you can actually gain access and be able to run malicious commands on the system. However, we are just using Ben here. So the next thing to do now is to perform post exploitation, and the first thing I normally do is to load the plain piece up, but I want to actually point out the reasons to always do manual enumeration on boxes first. Now, running the ls command, I'm actually inside the var.whcl folder, as you can see, and you can see the rev.php script which was created. So the next thing for me is to actually stabilize this shell, because I need to get a very good shell. I don't like this shell. I need to get a perfect shell. So I'm going to type in the script -qc/bin/bash command, and then I'm going to get a long shell like this, as you can see. I'm going to hit Ctrl Z on my system, and I'm going to type in stty then raw-echo. I'm going to send it to the fg command, and then okay, I have raw there, raw there, so I need to hit Ctrl Z again. Sorry about that. I need to type in raw here. Nice. So raw-echo fg. So I'm going to type in export stem equals to xstem-256 colon. Once you type that in, now you will actually have a stable shell, and even after doing Ctrl C multiple times, you will not lose your shell. So now I can actually navigate. The first thing I do is to navigate to this user home folder, which is cd/home, run ls, and I have Ben. Now when I run ls in Ben, I literally have the user.txt file. This is where the normal average user or a lower level user is actually stored. Their flags are always stored in a user.txt file under their home directory. However, what we need to do here is to perform privilege escalation. Running sudo-shell, we actually have permissions to run usr/bin/bash user Peter, meaning we can actually spawn up a shell as user Peter. Now I'm going to spawn up this shell. I'm going to do sudo, because if I actually do sudo and then I paste that user bin/bash and I enter this here, it's going to ask me a password for Ben, which is not supposed to be like that. The reason why I'm getting a password for Ben is because I'm not running this command as Peter, I'm actually running it as user root. Remember that the sudo command literally runs any other command or any other binary as the root user, right? So I'm going to do sudo then -u and I'm going to place a Peter here and paste in the binary. Now this will give you a shell as user Peter, as you can see right here. Running ls, we can actually see we don't have permission to read Ben folder, which is fine. We can actually navigate to our home folder, run ls-la to check if we have any other compulsory folder. But as you can see here, we don't have any important file, as the bash history here is typically bash history here is typically piped to dev, no, meaning that any stuff that is saved to bash history is not actually going to be saved. Like the file is not actually going to be saved. So what we can do here is we can tend to enumerate more. However, I told you I've played the box previously, and after several enumeration, even after loading limpies, which we can do, we can cd to /tmp. I'm going to split this terminal and navigate to /tmp, and I'm going to load limpies for you here just to show you what I mean. I'm going to start up a Python server here. You can go ahead and download a limpies binary or lin-enum.sh. You can search for lin-enum.sh download. Just search for lin-enum.sh download. Whichever one is comfortable for you, you can actually download it. So I'm going to download the lin-enum.sh script, which I feel like is what I should actually use for this particular lab. Yeah, so I'm going to copy the file and I'm going to save it on my local system. I'm going to be using the nano text editor, so I'm going to do something like nano lin-enum.sh, and I'm going to paste the content of that stuff and then save it. Now I'm going to set up a Python server, a Python 3 server so I'll be able to transfer the file to our target machine. Right now we can actually transfer the file to our target machine by pasting the IP address of the host system, which is this IP address here, and then adding a slash, then calling the name of the file, which is lin-enum.sh. As you can see, the file has been downloaded to the /tmp directory. You can then grant it executable permissions and then run the script. As I said earlier, I typically was able to download exploits for the Linux kernel, but nothing was working. It looks vulnerable to dirty pipe, but was not working. The sudo privilege escalation also was not working, which was actually vulnerable to some buffer overflow or heap overflow attacks that leads to RCE. However, after several enumeration, I found out that the user Peter was just a rabbit hole. That is why I decided to do this YouTube video, to show beginners how rabbit holes are very compulsory on each boxes. It took me almost 30 minutes to realize that user Peter was actually a rabbit hole. Now I can go ahead and exit for user Peter and running id command here. I can see that the Ben user belongs to the disk group. Now any user that belongs to the disk group and has excessive permissions on this disk on some particular drives, like under the /dev folder, can actually perform privilege escalation to root, because the disk drive is actually running that dev folder as root privileges, and is not going to drop that privileges. Why? Because we belong to the disk group. So you can go ahead and search for disk group privilege escalation. Now you can always use this website for a lot of things, right? So not just disk builder installation. Now we can use the find command to actually find for disks, right? But I prefer the df-h command because it actually tells you the status of what the drives are in. Now you can see the different disks here, and you can see used 22%, available 5.1 gig, used 1.5 gig, size 6.9 gig. So what we can do here is that we can actually use this dev/sda1, which is the file system that I'm pretty sure they literally used here. Okay, they used sda2. So what we can do here is we can copy this command also, but instead of using sda2, just change it to sda1. Now you can actually run actual commands here. What do I mean? If I run who am I can actually see who am I, right? But I can actually cut out this root ID RCE file, which is actually a private key for all SSH for the SSH service, right? So I can do root.ssh/id_RSA, and then I'm able to read the root RSA key file. Now if this is correct, literally I can actually be able to connect via SSH as a root user. So go ahead and copy this particular SSH key. You can open up a new tab and then save it inside the file called id_RSA. Now we're going to hit enter there. You're going to save it, and then you are going to grant permissions of 600 to the file, which is the id_RSA file. Once you grant the 600 permission, you can actually run the SSH command followed by the -i to specify that you want the id_RSA key file, followed by root, and then the IP address of the machine, which is 192.168.0.116. Now you hit yes here, and then the id_RSA key requires a passphrase. Sometimes most users think that the id_RSA key cannot be acquired, and sometimes most users think the id_RSA key can be acquired. So what they do is they actually add a passphrase to that id_RSA key, so anybody with the id_RSA key cannot actually connect to the particular machine if they don't know the password. So what we first of all need to do is to crack the id_RSA key. You can go ahead and do SSH to John. It is actually a jump binary here that actually converts the id_RSA key to a hash in which we can actually crack, right? So we can go ahead and use this command, and if I cut out hash.txt, you can see the hash. So I'm just going to specify John, then hash.txt followed by the word list. You're going to do --word list here equals to, then you specify a path to Rocky user shell word list, then rocky.txt. This should crack in few seconds, which is actually going to give you the passphrase for that file. As you can see, the passphrase for the id_RSA file is shelly, pretty weak. So we can go ahead and clear our screen, scroll up again, and connect via SSH, and now we should be given root access. If I run who am I here, you can literally see I'm root, and then if I run hostname CTL, you can see I have all privileges. Running ID actually have all privileges to this machine. Now just in case you want to log into this endpoint, because we never knew the root login at first, you can go ahead and you can go ahead and nano into this stash. This is a form of persistence, not just for this book but for any box. Just in case you don't know the id_RSA file, we can go ahead and create another root user without creating another root user. You might ask me, what do I mean? This is what I mean. First of all, I'm not going to save this, but instead I'm going to run the OpenSSL command to actually generate a new password hash, and I'm going to call the password bound high. Now I'm going to copy this password, and I'm going to nano into the etc/password folder. I'm going to paste in that password here, copy it from here down. I'm going to copy from here down, and I'm going to paste it at the end of this file. I'm also going to come over to the beginning of the file, and I'm going to name it root1 and put a semicolon there again. So typically this is how yours should be also. Now once this is done, you can go ahead and say file, and then you can actually switch user to root 1, and this is going to ask you for a password so that you can specify bank card. But right here we are root already, so we don't need that. So what I can do now is I can try as login as root on this particular import. If I try using root as the username, if I do root and then I type in bank card, you will see it will give me an invalid password, right? But if I actually do root 1 and then I type in bank card as password, can you see I'm actually root here? This is another means of persistence that I've just taught you. I hope you learned something new in this video, and please make sure to like and subscribe if you actually learned something new. Thank you.